Welcome to myprojectBazaar.com. Now we are going to discuss about the project virtual assistants for the visually impaired. Now we are going to discuss about the abstract of the process. The voice assistants we have developed in the desktop-based build using the Python modules and libraries. This assistance is just a basic version and could perform all the basic tasks which have been mentioned above, but the current technology is, although good in this, still to be merged with the machine learning for better classification. Hence in this process we are achieving the process with the deep learning. Hence in this process we developed the system which recognize the voices from the dataset and then corresponding response will be done. So the dataset consists of lot of voices. The process works on the three stages like pre-processing, feature extraction and classification. Based on the above mentioned steps, the process recognizes the voice and then the response is done by using the convolutional neural network algorithm. Then the final stage of the project will consist the performance analysis. By that performance we can justify our process is efficient or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The process consists of the module such as input signal, pre-processing, feature extraction, classification and performance estimations. So first of all, the input signal is taken from the dataset. So the dataset consists of the voices of various signals. After getting any one signal from the dataset, the pre-processing will be carried out. In this pre-processing stage, the signal will be reshaped. So during the signal reshaped, if the length of the signal is more, means it will be reshaped into one particular sizes. After getting the signal is reshaped, we just move on to the third stage of the project, that is the feature extraction. So feature extraction is nothing but the collection of data. So this is a kind of the signal, so we have to collect the data like an pitch, peaks and then the intervals. So based on that we are using one algorithm named as GLCM. So by using this algorithm we can estimate the pitches and peaks values separately. So after extracting the features from the signal, we are just go to the classification stage. In this classification stage we are using the convolutional neural network for the classification. So in this classification it will classify which kind of voice input is there. So for example, when the voice input is 1, means it will recognize the 1 and then do the corresponding activities. After doing the classification we have to find out the performance estimation. So the final stage of the project is the performance measures. So in this performance measures we have majorly considered the performance parameters like accuracy. So accuracy is justify the process is efficient or not. If the accuracy is above, means the process is efficient. If the accuracy is low, means the process is inefficient, because the reason is if the accuracy is high, means error rate will be the low. If the error rate is high, means accuracy will be the low. So we have to find out the accuracy based on this four parameters like true positive, true negative, false positive and false negative. Now we are going to discuss about the running procedure of the process. At first open the Spider 3.7, then change the current directory. If you want to execute the file, just double click in the main file.py, then you just click the run button. After that one dataset will be open. In that dataset you have to select any one signal from the dataset. After the selection of the signal from the dataset, the corresponding process will be done automatically. Now the process was done. At first the original data, that is the original signal, will be taken from the dataset. This is the original signal we have taken from the dataset. So after that we have to pre-process the image data. So in this data we have two kinds of pre-processing. One is the signal limitation and then the signal noise removal. So if the signal limit is short, means no need for the signal limitation, otherwise we just move for the filtering alone. So first of all we have applying the filtering to pre-process the data. So after that this is the final filtered signal. So you can see the difference between the just pre-processed data and then the filtered data. So after that we have to extract the features from the signals by using the CNN as well as the mean, standard deviation, variance, minimum and maximum for extracting the basic details from the signal. So after that we are applying the CNN model to testing and training the data. So this is the layer assignment of the CNN to extract the basic features from the signal. After the extraction of the features, we just move on to the classification stage. In this classification, it will recognize the which kind of input is there. Here we have giving the signal as 1, so it will recognize the signal as 1. So the recognized term is 1, that is the numerical 1. So after the recognition part, we just move on to the classification performance stage. So in this classification performance, we are going to estimate the accuracy and error rate. So this is the overall accuracy we have achieved in this process, 99.2%. So the universal proportional is error rate. So the error rate will be the inversely, so around 0.8 something is the percentage of error rate. Thanks for watching this video.